Hello and good day everyone. Today I'm going to share with you about an interesting theorem. But first, let me introduce myself. My name is Siti Nuratika Haria binti Muhammad and my fellow friends. The theorem that I have mentioned before is Green theorem. Green theorem is a special theorem that exists for closed curves. It is a simple closed curve that labels C as the region R. It is the other way to calculate a line integral. The Green theorem functions to convert the line integral into double integral by using this formula. This is very useful theorem as line integrals are typically harder or more complicated to calculate than ordinary integrals. It is important to know that Green theorem applies to closed curves that counterclockwise, which is a positive orientation. For curves that go in clockwise direction or negative orientation can still be applied but with a sign change, which is a negative sign right in front of it. For a quick consider, the curve C given here where three line segments make a triangle. The line segments are straight line from 0, 0 to 1, 0 to 1, 1 and finally along the line y equal to x back to the origin. If we want to integrate y first, in our double integral, y will run from 0 to the curve y equal to x. So x is the upper boundary, meanwhile x will simply run from 0 to 1. Then the line integral from 0 to 1 and then from 0 to x. For more understanding, Najiha, Warta and Natasha are going to go through some questions and details about Green theorem.
Assalamualaikum and hi. My name is Nurul Ainajiha binti Muhammad Johari. My metric number is B011910230. So, in this video, I would like to share about how to calculate by using Green theorems. Here's the question. So, if you got this kind of question, you have to find out where is the info. So, this is the question and this is the information given. And also, this is the most important info. So, as you guys know, when you have this coordinate, we can take it as an oriented for region. So, how to calculate by using Green theorem? Here is the formula. Work done is equal to line curve C f dot dr equal to double integral dg with respect to x minus partial df with respect to y over d area. So f is equal to 1 plus x of the power 3 and the power of 1 over 2, which is the square root, and that's function belong to f. Meanwhile, 2xy is belong to function g. So we have to differentiate the function f with respect to y, and we get 0. And differentiate function g with respect to x, we got 2y. So we got the coordinate, hence we have to plot and make it triangle, which is positively oriented, so it anti-clockwise. And then we have to find the equation for y because we have to know the boundaries of y. And then we got the boundaries of y 0 until 3x, and then the boundaries of x 0 until 1. So this is the formula for Green theorem. We have to double integrate of the function dy and dx. 2y minus 0 is the function of dg over dx minus df over dy. So first we have to integrate 2y with respect to dy, and then we got 2y squared over 2y, and then we have to put the limit, and we got 9x squared, and then we have to integrate with respect to x. We got this x cubed over 3, and then we have put the limit, and then the final answer we got is 3. Thank you.
Hello, hi, my name is Warda Turaza binti Muhammad Sulaiman. So, I will proceed to the next example, which is Green theorem. So, here the question, and let's proceed to the calculation. Okay, first, let's notice that this part does have the positive orientation, and we can solve it by use Green theorem to evaluate the integral. Also, given the coordinate that we can substitute it into the equation. Alright, from the integral, we have the function of f, which is x power of 3 minus yx, and function of g, 6y minus 9x. Then, we need to differentiate the function of f respect to the y, and we got negative x. We also do same to the function of g, which is we differentiate the function of g respect to the x, and we got negative 9. For the next step, which is step 2, we need to substitute this value into the formula that Najiha had explained before. Okay, so we got negative 9 plus x dA. For the step 3, we need to substitute the coordinate, which is we got x, we got negative 1 to 1, and y negative 1 to 3 minus x. Okay, let's move to the step 4. For the step 4, we need to evaluate the double integral here, and remember, the D is the region enclosed by the curve. Next, we need to solve the limit negative 1 to 3 minus x first to the function. Before that, we need to integrate that. Then we substitute the limit into the function. Next, we solve the limit negative 1 to 1, and we substitute it into the function. Then we got the answer, negative 218 over 3. Thank you.
Hi, my name is Natasha Nasuha binti Zainuddin, and I will present about the application of Green Theorem. As we already know, we use Green Theorem to find the areas enclosed by curve. So, we can say that Green's Theorem is a working principle of planimeter. Planimeter is a mechanical device used to measure areas enclosed by closed curve on paper. Green's theorem connects the surface integral to a path integral. Another real-life application of Green's theorem includes using the reciprocity to evaluate the excitation from an impulse in waveguide or antenna designs. Green's theorem allows certain types of reciprocity, which is a natural law, to be explained by a mathematical theory. That's it about my explanation. We can conclude that Green's theorem is very useful in our life. We hope this video can make you understand, remember, and know how to apply the Green's theorem concept.